This podcast will be on the steps in the process of making urine or urea, the semi-solid waste material. So basically on the board here, I have a Nephron, and it's not a fancy Nephron. I just have Bowman's capsule. I have the PCT in the same color, green. I have loop of Henle. I have DCT in blue. Arch tube does nothing. And then it just moves the material to the straight tube. And that's the end of the Nephron. So what are the 4 steps I'm going to talk about in making and producing the waste material, the semi-solid waste material? Well, the first step is called filtration. The second step will be called absorption. The third step over there is called reabsorption, whatever that is. And secretion is our last step. So there are 4 basic steps. And so here we go. So we're going to start with filtration. So what does filtration mean? Very simple. The plasma leaks out or diffuses out of the glomerulus into Bowman's space. So here is step 1. Here is our plasma right here, and it's going to come out by simple diffusion, and here it is in Bowman's space, right there. And what do we call that? It is called filtrate, right. So the plasma is going to leak out, and it becomes known as filtrate. There it is. And so that is filtration. It is the simple process of diffusion of the plasma out of the glomerulus into Bowman's space. And we can actually time it. There is a medical procedure or test in which basically when you micturate into a cup, you just take a stopwatch and you look at the amount of time you micturated versus the amount of a liquid that's in your cup. And they call that the glomerular filtration rate, the GFR. And so basically for males and females that are adults, anywhere from ages 18 to 60, it should be 115 to 125 mils or cc's per minute, okay? And so there it would be, right there. So you can also get an estimate of your GFR by blood work. They also do that. There's a algebraic equation that they can do based on the volume of your blood. All right, so that is filtration. So plasma leaks out into Bowman's space. All right, now basically the filtrate is going to do what? The filtrate moves down here into the PCT lumen, okay? So think straws, like on my little design. And so here's the lumen, and here comes the filtrate, right? Right. So now the next step is going to happen. Step 2 is called absorption. And what does absorption mean? It means the substances move from the lumen of the tube, right here, from the lumen of the tube into these green cells, okay? So now this is going to be step 2. There's material that's going to diffuse or do active transport into these cells, okay? Into these cells right here. And so that is step number 2 called absorption, all right? So this is 2, which is absorb, right there. This is step number 1, filtration, right? And so step 1 up there. This is step number 2. It's going to happen right here. And does it happen all the way down the tube or all the way down the nephron? Yes. And so this is going to keep going. Whatever is left over is going to keep going into the loop of Henle, and it's going to absorb some items into its cells. And then what's ever left over is going to keep moving up to the DCT, and it's going to absorb whatever it needs to absorb. And then it's going to go through the ACT, and the ACT does nothing. And so in the straight tube right here, it's going to absorb certain items, okay? And so right here, so that would be step 2 right here, and so absorb, okay? Absorption, number 2 there, number 2 here, absorption, right? And so here, number 2, absorption. So now, what gets absorbed from that leaked plasma, essentially from up here? What's going to be absorbed? So let's do the easy part first. The loop of Henle, the DCT, and the straight tube, they don't absorb as much as the PCT does, because the PCT, oh my gosh, it has all these microvilli for increased absorption of all the substances. So essentially, let's do the loop of Henle first. The loop of Henle only absorbs water and salt. That's it, okay? Water and salt. And so absorption, water and salt. Okay? Water and NaCl. Perfect. And then what gets absorbed in the DCT? The DCT is going to be water and some sodium, okay? Some sodium. And so DCT absorbs water and some sodium right there. The arch tube does nothing, thank goodness. And then we have the straight tube, and it only does water, okay? Water, and so right here, it's gonna absorb H2O. Loves to absorb water, all right? So those are the easy parts of the nephron to get in terms of what they're gonna absorb from the uric acid out here in the middle. That's all it's gonna absorb from this waste product in the middle, water and salt. And then when it gets to the DCT, water and some sodium, maybe. And then basically, when it gets to the straight tube, it's gonna absorb water, okay? Now, here's the big item right here, the PCT. Oh my gosh, is it gonna ever absorb a lot of materials? And so basically, what's it gonna absorb? Now, if I say PCT, what's it gonna absorb? I'm gonna put everything. Everything. Oh my gosh, it can absorb everything. And so what does it like to absorb? Oh, water, salts, electrolytes, glucose, blood sugar is going to come in here. All this is going to come in here. Drugs, hormones, alcohol, waste products like ketones from the metabolism of fats, protein metabolism leftovers. Protein metabolism leftovers would be like ammonia would be coming in here. Uric acid, urea from muscle metabolism could be coming in here. Creatinine could be coming in here from muscle metabolism. So basically, it's going to have a lot of products, even poisons, if you ingested some poisons. So it can absorb everything and anything into these PCT cells, right? So everything is an understatement. On your note sheet right here, it says the kidneys and what it absorbs right here. And so basically, look at all the things listed on here. Of course, I said them all to you, but basically there they are, right? So that's what the main part of the nephron is going to absorb. Everything that it just leaked out, it's going to go in through here, and then we're going to do something with it. So whatever doesn't get absorbed back into these wall cells, the two wall cells, it's going to keep moving on out, and that's what it's called. So the waste products in here are called uric acid, and then when it gets to the DCT, it's called urea, all the way down to the bladder. But what do we call it in here? Filtrate. It's still called filtrate in the PCT. So this is still called filtrate right up here. All right, so that's essentially step number 2. And that's not hard to understand, is it? No. So I wish it would just stop there because it's going to get a little more complicated. So now we're going to go to step number 3 over here. reabsorption. So what is reabsorption? So the definition of reabsorption means, in terms of kidney physiology and anatomy, to move by diffusion or active transport from the tube cells, tube wall cells, into the vasorectal capillary. Uh-oh, now I have to draw a capillary over all these tube parts of the nephron. And so I'm going to use a unique color, which is sort of a violet color. And so watch, I'm going to put, here's my capillary. I'm going to make it go over here, and then come down here over these cells, and then come back over here, and then come back over here. And so here it is. I'm going to make a double wall like this. And so here's my capillary going over right here. And so these will have simple squamous ET cells like this in the inside, right here. Make them real thin. And so here is the vasorectal capillary, right here. And there are many of them, many right here. So they're just gonna randomly sit on top of these tubes, the nephron tubes. And so now we'll make the blood go this way, okay? So here comes the blood. This is the blood right here. It's coming. It's not real good, this marker, mixing with the other. So let me add a little more color. So here's my blood in the inside here. That's a little bit better. And so here's my blood. Okay, so this is making the picture nice and messy, but hopefully this will help you. Okay, so let's label this. This is the vasa recta capillary, okay? Right there. And that's the blood in the middle with blood. Right here. So there's my blood. And it's sitting on top of these tubes, on top of it. So like when I did my little design here it is. They sit on top of these tubes and they're just randomly placed. So not every tube has a piece of a capillary wound around it. And they're just randomly sitting up here on top. And maybe they'll get something put back into the bloodstream this way, right here. So right now, here we go with step number 3. So step number 3 means to go from inside here, inside these cells, and go through the wall of the capillary and get back into the blood. Get back into the blood, into this vasa recta, and then it's gone, okay? Then it's gone. So like here, this would be step 3. So you have to have a piece of a capillary sitting on top of your cells. So only these cells can do reabsorption, the ones that the capillary is sitting right on top of it. Not this one and not this one. They can't do reabsorption because there's no capillary sitting on top of them. So basically, it's got to go from underneath here. These cells right here are going to send their reabsorption materials back into, go through the wall of the capillary and put it back in the blood, right like this. So it just reabsorbed something. Now what gets reabsorbed? Whatever you absorbed into the cells can be reabsorbed right back into your blood. So if you absorbed a whole hunk of bacteria into these cells, you could put that bacteria, reinfect yourself, right back into your bloodstream, into the VR. So if you took in a lot of glucose, blood sugar, okay, great. You're gonna put that blood sugar right back in. So you reabsorb it, exactly. So whatever you absorbed, you essentially can reabsorb right back into that capillary. So now if we're down here in the loop of Henle, what are we gonna reabsorb? Water and salt. And so again, it would like here's some water and salt in these cells, and then it can actually move through the wall of this to get back into your bloodstream, right there. So you're reabsorbing it. So it can't be on these cells, because there's no capillary sitting on top of it. And then when we get over here to the DCT, all the DCT is going to put back is water. Sodium does not get reabsorbed. And so basically, it says that on your little chart right here in your table. It's only going to be water that gets reabsorbed here. So you have to have, you can't do that, only water. Only water gets reabsorbed right there. So that's what the DCT does. So why do you want to reabsorb all this water? To help maintain blood pressure. And so blood pressure is a measure of the amount of plasma and dissolved solutes and the cells against the wall of the BV. So this would be your blood. And so if you don't have enough blood, your lumen is going to shrink, and then it will be stuck together, and then you're going to die because your blood's going to back up because you don't have the lumen open. And so you don't want low blood pressure because that's going to kill you. And so if you have high blood pressure, you've got way too much stuff in your blood, and it's opening it up like that, and the lumen and your wall of your blood vessel becomes like a balloon, and it becomes thinner and thinner, and eventually it'll pop. That's called an aneurysm, and then you're dead too. All right, so that's high blood pressure, hypertension. And so anyway, you don't want that either. So you want to keep the volume of blood pressure just normal, so it goes through nicely and it doesn't make the wall expand and explode. Wonderful. All right, so that's reabsorption. And so then water is the only thing that gets reabsorbed also in the straight tube. And so again, you'd have to have water sitting in these cells underneath, and then it will go back and get reabsorbed into the blood. Right. So that's easy. That's not too hard to understand, and that helps you with your blood pressure. And so by filtering your blood and going through all of these 4 steps, even though we haven't done the 4th step yet, this is the way you maintain blood pressure every day. You don't need hormones to do it, but basically hormones will help it and basically adjust your glomerular filtration rate. But basically, that's the 3 steps that really help maintain blood pressure. Now the 4th step will also help maintain blood pressure. And so what is secretion? Secretion is like reverse reabsorption. And so secretion means to go from the vasa recta. So now you're going to go from the vasa recta, you're going to take this blood, things out of the blood here, you're going to go through these cells, the vasa recta wall cells, the capillary cells, into the cells that you just absorbed from, reabsorbed from. And so you're going to go from the vasa recta into these cells, and then into the lumen, and then you're out of here. So you're going to throw back stuff back in to get rid of it. You're going to pull it out. And so this is a way we can control blood pressure also with diuretics. Diuretics work on 3 tubes. Diuretics work on the loop of Henle. They work on the DCT cells and the straight tube cells to pull water, sodium and water, one way or the other. And so anyway, depending upon what drug it is. And so basically, secretion means to go from the vasa recta back into the tube wall cells, and then into the tube lumen, and then it's out of there. And so secretion, this is really big for diuretics. Loop of Henle. What is loop of Henle going to secrete? It's going to take water out of the vasa recta, and then it's going to put it into these cells, and then it's going to put it back into the lumen. And so it's going to be a reverse. So it's going to take water and go from here through the wall of the capillary into these cells, and then it puts it into here. And so that is called secretion. And so it does water right here. That's step 4 right there. And so step 4 right here. Step 4 doesn't want to write. 4 right here. So you're going to go from here into here into here, and then you're out of there. And it's not going to be absorbed or reabsorbed as it goes and continues out. It's going to go backwards and out. And so that's what gets secreted in the loop of Henle, water only. The DCT, oh my gosh, it's going to pull a lot of things out of your vasa recta. And so it's going to pull out, it not only pulls out water for number 4 for secretion, potassium is a big one, and then creatinine, which is a waste product from skeletal muscle movement, and hydrogen. And so hydrogen can also be pulled out in this step, hydrogen and creatinine, right? And this is all on your table right here also, exactly. All right, and so that's what gets secreted in the DCT. So if you're on a diuretic and it's pulling extra potassium out, and that diuretic is specific for the DCT tubes, basically you've got to be supplemented with a potassium supplement of some sort, or a dietary thing to help you so you don't lose so much potassium. And then of course we have the last tube that's going to do secretion, and it's the straight tube. Straight tubes, that's all they do is deal with water. And so essentially water is going to come out of here, out of the blood, go through the capillary wall into these cells, and it's out. It's going to be out. Here goes the water from the straight tube. So that would be step 4 right here. Step 4 is going to go from here to here into these cells into the lumen, and there goes the water, right? Step 4. And so that is the last step. So all 4 of these steps essentially help maintain blood pressure, right? By just actively cleaning your blood and removing some substances, putting it back, and then also it also gets rid of your waste material, the urea and the excess water, and that will eventually create urine when it mixes together in your bladder. So that's the steps in making urine.